Well, section 13.3 is about arc length. First, a reminder from Math 3A. We actually found arc length way back in Math 3A. So you've got this function f of x. It goes like this. On an interval from a to b, then find the length of this curve right here. And the formula is that you put 1 plus the derivative squared inside a square root and then integrate. Essentially, it comes from the Pythagorean theorem, and you draw little triangles in here, etc. Then in Math 3b it was done again. In Math 3b, we would have a parametric function. So x, let's say, equals a function of t, and y is equal to a function of t. And then the arc length would be, well, now that you have two functions, you need to take two derivatives. So take the derivative of the f with respect to t, take the derivative of the g with respect to t, then square each one of those, which is basically coming from this formula. Put all that inside a square root, and then integrate whatever the interval is, let's say from a to b. So in Math 3c, the only difference is we now have three variables, x, y, and z. So if this is f of t, and this is g of t, and then let's say this is h of t. So for arc length, it's going to be integrate over whatever the interval is, let's say a to b, and then you take all three derivatives. And square each one. And after you square each one, then put all of that inside of a square root and integrate with respect to t. So that means that it's just one extra step right here compared to in Math 3b. Now notice this is basically saying take the derivative of the function, square each component, add them together, and then take the square root. That's also the way that you find the length of a vector. And because this is the derivative, that means that this, with square root and everything, is actually the length of the derivative of the function. So this is just a faster way to say the same thing. Take the derivative, which is the tangent vector, and then find its length, and it creates this right here. So now for a couple of examples. So to begin with, how about some trigonometry? Here we go. So for example number 1, the function r of t will be 3 sine t, 3 cosine t. So that part right there would make a circle. It would be a circle of radius 3. And then it's going to go up because the z value is going to be the square root of 5 times t. And then this one's going to be on the interval from 0 to pi over 4. All right, so find the tangent vector and arc length. So I don't know if you noticed, but I just took a quick break because I went to look at the homework, and it says actually find the unit tangent vector. So tangent vector means just take the derivative. So the derivative here would be 3 cosine of t, and then negative 3 sine of t, And the derivative here would just be the square root of 5. So there is the tangent vector. Unit means make it a length of 1. So what you need to do is then divide by the length. So the length, which is actually good because that is what we're going to need to integrate, so we're going to have to find it anyway. So the length is going to be the square root and then square each component. So this one is going to be 9 cosine squared. And this one will be 9 sine squared. And when you square that one, it's just going to be a 5. Now this could even be simplified more because in here you could factor out a 9 and then it would leave cosine squared plus sine squared, which equals 1. And then there would still be this plus 5. So it turns out that it's just a constant square root of 14. And the unit tangent vector, oh hold on, this is the tangent vector. And then the unit tangent vector is take the derivative divided by the length of the derivative. So this is going to make it 1 unit when you divide it by its length. So just take this one and divide by its length. So you could just do that with each component. So it'll be 3 cosine of t divided by the square root of 14 and negative 3 sine of t divided by the square root of 14 and then square root of 5 divided by the square root of 14. Okay, so this is also called capital T for the unit tangent vector. Now find the arc length. So we need to integrate this guy, which actually simplified to just be that. And then integrate it on the interval from 0 to pi over 4. So integrate from 0 to pi over 4. And then I feel sort of ripped off because I thought it was going to be this nice complicated integral, but all we have to do is integrate the square root of 14. So that means it's going to be the square root of 14t evaluated from 0 to pi over 4. So that'll be the square root of 14 times pi over 4. And then when you substitute the 0, that's just going to be 0. So this one is already done. Then for the next example, so I'm going to throw in a little bit extra, which they don't actually cover in this section, but we do need to be able to do it, and then it's going to turn into one that is in this section. So for example number 2. So you've got one surface, x squared equals 2y. And another surface is 3z equals xy. And then we're going to find the arc length where they intersect. And they intersect forever, so it's just going to go from the origin to 6, 18, 36. So this is the extra part, which we're definitely going to be using a lot in the future. So these are the surfaces. Hopefully you can see that without too much of a glare. And so they are intersecting here, and then here, and then here. And so it's a curve where they intersect. But this one is saying go from 0, 0, 0, and then along here. So we need to know what's the equation or what's the function that creates this where they intersect. So notice in here there is no t. So we need to introduce the parameter t ourselves. Let x equal t. That's it. Then substitute that in there and solve for y. So in other words, divide by 2. So this will be t squared and then divide by 2. So y is equal to t squared divided by 2. And then over here, solve for z. So z is going to be x times y divided by 3. But then replace x with this and replace y with this. So z is equal to x times y, and then both sides need to be divided by 3. Or in other words, our function that is giving us where these two intersect is going to be t, comma, t squared over 2. And then this will be t cubed. And when you put these two together, it's going to be t cubed over 6. Now, what about this? Well, if it's 0, 0, 0, that must mean t equals 0. And if this has to be a 6, this must be a 6. And if you square it, that would be 36 divided by 2 is 18. And if you take a 6 and cube it and then divide by a 6, that means it's really 6 squared. That's 36. So in other words, from t equals 0 to t equals 6. So this is the extra part that we definitely need to be doing in the future. This is what they would ask you on the homework, specifically in this section. That was just a little preview. Okay, now we need the derivative. So that would be 1. The derivative here would be 2t divided by 2, so that's just t. The derivative here would be 3t squared, but then when you reduce it, it's going to leave t squared over 2. And then find the length of that vector. So that's going to be the square root of 1 squared plus t squared plus, when you square this, it's going to be t to the 4th over 4. So that's the thing that we're going to get to integrate. And then I'm wondering, could this be simplified? Because in order for us to integrate a square root, you either have to use some fancy trig substitution or the square root has to be simplified. With this one, I think it can be simplified, because this thing right here could be factored. It could be factored into 1 plus t squared over 2. So square 1, that's right. The middle term would be this times this, and you double it, which is that. And when you square this, it gives you t to the 4th over 4. So that means that it simplifies to just be 1 plus t squared over 2, because the square root and the square will cancel each other out. And now I need another piece of paper. So the unit tangent vector will be the derivative divided by its length. So that's going to be, well, you know what? I could rewrite this one, get a common denominator, so this is 2 over 2. So it would be 2 plus t squared over 2. So the unit tangent vector will be 1 comma t squared over 2. And then that needs to be divided by the length of 2 plus t squared over 2. And then invert and multiply. So multiply by 2 over 2 plus t squared. And then go ahead and distribute that. And so the first component is going to be times 1. The next one is going to be multiplied by t, so that'll be 2t over 2 plus t squared. And then for the last one, so on the top there will be 2t squared. On the bottom there's already a 2, and then we're also having a 2 plus t squared. So there's the unit tangent vector. Now the next thing is find the arc length. So that is integrate this one, the length of the derivative. But remember, that actually simplified to be this. So this is what we actually need to integrate. The 1 plus t squared, so arc length equals the integral of 1 plus t squared over 2 dt. And then back over here, I found out that it's from t equals 0 to 6. So from 0 to 6. And then that's just going to be t plus, let's see, this is going to be t cubed over 3, which means it's t cubed over 6, evaluated from 0 to 6. So substituting the 6 means it's going to be 6 plus 6 cubed over 6. And when you substitute 0, that's going to be 0 and that's going to be 0. So this contributes nothing to the answer. So finally, the arc length would be, this is 36, because when you simplify it, that's 6 squared. So that's 36 and 6. The answer to the universe is 42. Now, I want to do one more. So for example number 3, with this one, just find the arc length. And then the function is a t e to the negative t and t e to the negative t. And then t is going to range between 0 and 1. All right, so we need the derivative. The derivative will be 1 for the first part. With this one, it's going to be e to the negative t, but then because of the chain rule, multiply by a negative 1. And then over here, I need to use the product rule. So the derivative of t is 1, and then leave e to the negative t alone, plus leave the t alone, and take the derivative of e to the negative t, and then do the chain rule. So that is going to simplify to just be 1 negative e to the negative t, and then e to the negative t minus t e to the negative t. All right, now, so we're integrating from 0 to 1. That was given. And now I need to square all of these. So there would be 1 squared. When you square this, it's going to become positive. And when you square its exponent, that actually multiplies it by 2. Because when you raise it to the second power, or power raised to a power, you multiply. So then it's going to be plus e to the negative 2t. And then I also need to square this. Okay, so I worked this one out before I turned on the camera, and it turns out that this one cannot be simplified. I thought it was a cool problem, but I should have either changed it, but then again, I just didn't want to change it. I like that function. So when you get to this point, there's times when you can't find the antiderivative, so you need to use a calculator to estimate it. That's what we're going to do right now. Estimate this integral. So if you haven't done this before, you basically pretend like you're going to graph it. So go to y equals, I need just regular mode, not parametric. So it's the square root of 1 plus e to the negative 2x, and then plus parentheses e to the negative x minus x e to the negative x, and then all of that gets squared. So let me make sure I've got all the parts. The square root, the 1 plus the e to the negative 2, and I've got this guy in parentheses, and it's squared. Okay. Then go to the graph, and it doesn't really matter what the graph looks like, but the graphing calculator just needs this part done. So you see that little circle there? That means it's still thinking about it. Good job, calculator. You're doing it. Okay, then go right here to second calculate and use number 7 to integrate. And we're integrating from 0 to 1. So from 0 to 1. And then it even fills in the area, and our integral turns out to be a 1.27.